Welcome, everyone, to another episode of the technical series for hashtag Real Talk with me, your host, Aaron Bregg. We're going to go down a rabbit hole on this technical episode. We're going to be talking about certificates and the learning the mysteries of them and doing a deeper dive. So grab your psychedelic tea or whatever beverage you want to have to open your mind to some awesome technical conversations. I'm going to take a minute and to introduce my esteemed guest, who is going to be our guide in this journey. Jason, please introduce yourself to the listeners and the viewers and tell me a little bit about how you got into the wonderful world that is information security.
Oh, very good. Thanks, Aaron. Jason Link, I'm a security engineer for 20, 25 years now. It seems like just yesterday. Um, I've been exposed to local government, healthcare, manufacturing, um, served a variety of different roles from network administration and then that kind of thing. Hey, back in the day, if you knew firewalls, you could manage VPNs, you were the security guy. Like, check, done. Uh, Obviously, the landscape's much different now, right? But for me, one of the things that is kind of a common thread throughout my career is certificates is always that thing of the arcane. Folks don't, um, especially in IT, they don't deal with it a lot. They don't work with it enough to really live and breathe it. And then even within security teams, there's oftentimes folks are like, yeah, I don't know. So that's always been kind of a curiosity for me, and this work is kind of a um, branch off of that. Call it my passion, if you will. Gets me excited. I have fun with it. So
That's all, that's always a good thing. And then a little side note, I've known Jason for a couple years. He has been a staunch supporter of the Cloud Security Alliance, and his manufacturing security prowess is pretty darn good too. Okay, so quick disclaimers, those of you that are already proficient in SSL certs and certificates in general, what I'm going to do is I'm going to spend a few minutes at a high level to talk about that so that if there are any, newer, not experienced listeners, they can get up to speed, so to speak, before we start really diving in. And Jason's got a slide deck. So for those of you listening to the podcast, I'll do my best to explain what we're seeing. And then obviously the people on YouTube won't have to worry about the explanations because they will be seeing it. Okay, Jason, at a high level, talk to me about certificates. What
right.
what's SSL? What's certificates? Like at high level, what are we looking at here?
So whenever people talk about certificates, there's a lot of pieces to it. Most people they hey, it's am I supporting TLS 1.2? Am I supporting the latest cipher suites, the certificates, certificate chains? There's a lot of different pieces to this thing about websites and TLS. What I'm focused on and specifically zeroed in on is that X509 certificate, that thing that provides authentication to the world, to your web browser of your bank is indeed your bank. Your medical environment is indeed your medical environment. It's not evil.medical, it's not evil.bank. Certificates are used primarily to provide a form of authentication to identify itself to whoever's connecting to it. Um, it does some other things, but it's really about that credential. Think of my government ID on the internet. Certificates are the ID or the identifier of these websites are authentic at a high level.
Which is kind of important in these day and age of like spoofing and stuff.
Yep, yep.
All right, we got that out of the way. So let's talk about scenarios a little bit. And if you want to get your slide ready, and I think I need to make sure that you can share. There, go ahead and see if you can hear.
So let me make sure I'm sharing on a screen size that's not going to be too small.
Obviously, this is a part we can edit. There we go. Okay.
All right.
Yes, it fits the screen perfectly. All right. So let's talk scenarios.
Let me move us to the side somewhere. Would you prefer me over here?
Yeah, looks good to me.
All right. So, so for me, when it came to certificates, my journey took this very long, wandering path. Part of this talk is the intent here is to try to shorten that path. You don't have to follow my same journey. Um, there's really four use cases of why we're talking about this. The first use case is um, I'm a Linux admin. I've got Apache and I inherited this environment and there's been four admins behind me and there's all these different files on the file system. How do I correlate the private key to the signing request to the signed public key? How do I do that? Um, the other scenario is, hey, how do I inventory my keys that are out there, my certificates? We talk about some of these data breaches that are related to, or these security incidents that are related to web environments that people didn't know were out there. And then the other piece is, can I prove certificate rotation? We talk about rotate your passwords. I mean, that's for users. That's pretty easy to put our hands onto. Hey, wait, you've got an issue. Let's rotate our API keys. That's a little bit more troublesome, but it's doable. But when it comes to certificates, X509 certificates for websites, how do we how do we do that? Can we validate that we rotated that? I've got a compliance requirement. Pick your compliance body. How do I prove that I've rotated my keys? Can I do that? And one of the things that we'll talk about in this is that the fields that we typically gravitate toward don't tell us the complete picture. And so we'll dive into that. And then the last one is, can I make this key agnostic? Specifically, a lot of the tutorials out there that cover this first point, they talk about the RSA key and tracking its modulus. Well, when you looked at elliptic keys, they don't have a modulus, and so those commands fail. Well, what's the second half of that story? So that's really kind of the premise for this conversation, the work that I've done on this. Just try to answer for myself these key questions, no pun intended. Um, so, uh, yeah.
Right, let's jump in.
All right. So for me, I can't assume my audience, so I dive into a couple of these things. So um, a lot of this work is based on the digest, the message digest, or the hashing function, or the hashing algorithm associated with data that's fed into that algorithm. So back in my day, MD5 was the thing, and then later it was like, hey, no, that's MD5 algorithm. That's not strong enough. Computing power has gotten stronger. You need to do the SHA-1 series of digest algorithms. And then later it was SHA-1's not adequate. We got more and more powerful systems. Let's do SHA-256. It's one of the three out of the SHA-2 family of hashing algorithms. Um, the idea on this is we advance our digest algorithms as the computing power gets more and more powerful. We got to scale that. We got to move that up. We got to slide the bar up, if you will, with the times with our security algorithms. And so why this is important is these digest algorithms help us provide some semblance of not authenticity, but integrity, that the data hasn't been altered, it's not been modified, it hasn't been abused in some way. That the copy of the information that Aaron got, that I got, the same data that we've received. Um, Collisions are the key buzzword around digest algorithms that we have to be mindful of as the computing power gets more and more um, capable, if you will. Can we create two documents that we can feed into these algorithms and they generate the same digest? As that becomes more and more, there's terms for this, and I'm not a crypto analyst, so forgive me. Um,
No worries.
what's that?
I said no worries on that one.
Yeah. So as these algorithms become, or as these computing power gets more sophisticated, you'll see these, hey, there's somebody's provided a proof of concept that starts to shorten that time for collision potential. Not that it's been broken, but they're starting to show fractures in that armor that is message digests. And so the industry will like, hey, it's time to bump before we have a problem. And for the most part, the industry has been really good about being proactive about that. Can I elaborate on that anymore, or is that pretty
Yeah,
well?
no, no, no. Yeah.
Yeah.
Why I was gonna say why is that? We got a little bit of time. Let's dig into why is that, right?
Sorry,
Why do you think that is?
you lost me. I'm sorry.
No, no, no. Meaning like the is it a fear of right? I should have paraphrased this for you a little bit.
Yeah.
The
No.
fear of like, with quantum computing coming out and the fact that collisions, like you said, computing power as it advances, more chance for collisions and stuff like that. So do people need to pay more attention how digest are kind of managed now, or is it something, hey, kind of be aware it's coming, but it's not something that's like
Yeah.
here right now.
Absolutely. So I get it. So going back to how we started this conversation with TLS, there's all these different pieces that sometimes it's alphabet soup. I'm like TLS and cipher suites and certificates. And then in the certificates, you got all these fields. I'm like, oh my gosh, all of these things in my career, I've seen them progress. Back in the day, a 1024-bit RSA key, that was good enough. And then later it was like, no, 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 all the certificate authorities out there is like, no, you must be 2048-bit certificates, nothing less. And so it's digest algorithms is one of many different components within the TLS suite of things, if you will, that the industry pays close attention to. You've seen a progression from SSL version 2 to TLS 1.0 to 1.1 and then 1.2, and now there's 1.3. It's all a progression. So to your point, if you pay attention to like the Feisty Duck newsletter and um, the SSL labs that are out there, I mean, there's a number of different resources out there that talk about this stuff of, hey, there's some change coming. Hey, the browser consortium, the CAB, um, Certificate Authority and Browser Consortium out there. They come out with these guidelines. And if you're not familiar with the CAB, it's basically all the CA authorities have gotten together. The DigiCerts, the Komodos, the VeriSign still a thing. Um, all the major players, even the web browsers, the Safari, the Chromes, the Googles, the not Firefox, but the Mozillas, they all get together and they're like, hey, we think that these changes would be a good idea to ensure the safety and the security of information that's out there. And that's why you saw an example of this. Sorry, I'm rambling. You saw a change a few years back where, hey, we're going to do 2-year certificates. And then shortly after that, like, nah, we're going to do 1-year certificates. That's just another, hey, there's a reason for it. Usually it's an operational component. People certificates are too long lived. Sometimes it's a, hey, computing power is getting more powerful. We're going to up the minimum base requirement for some of these things. Um, but we're talking about certificates specifically, not about cipher suites, not about protocols today. Although I could talk about them at length. Sorry.
If we had more time. All right, let's go to the next slide and dig in a little more.
So um, those digest algorithms, you feed some data into it, and you get some information out. In the work that I'm doing here, there's different file types. Uh, there's a base 64 ASCII file, or the text file, some people might refer to it as. On the right-hand side, you see this first one where I'm displaying the contents of this elliptic signed public key, and it's in PEM form, and it's somewhat readable. I mean, it doesn't make any sense, but it's alphanumeric. It's some text. It's got a begin certificate start, and it's got an end certificate ending. If you take that same certificate and you change its encoding type from um, a text document to, I'm going to slide this out of the way. Uh, to a binary form, distinguish encoding rules structured as an abstract syntax notation one format. It's binary. Um, it comes back to us when we try to display that in a terminal as gibberish, and it's because it's been encoded in a certain way. The best analogy that I have for this is, hey, that's a text document. Well, when you look at the document, you realize that it's a JSON document or it's an XML document or it's an INI document. When it comes to binary files, there's certain structures that those files can have in them. In this particular case, when we talk about dir encoded files, they are abstract syntax notation one, which is a structure, it's a format of how this data should be structured. All why this is important is because a lot of the work that I'm dealing with, I'm focused on the binary representation of the data or a subset of the data. It might start out in ASCII, but I convert that, and you'll see that in the conversations here. Um, just like if you write a document that says, "Hi, Mom," and it's a text document, or then you have a same version of that, but it's a rich text document, a PDF document, a Word document, same message. But if we encode that in different ways, we will get different digests when we run that through, say, SHA-256. And that's why we're bringing this up here to try to level set of hashing algorithms. Depending on what the data you're sending through it, you'll get a different digest. Even though it's the same certificate, it's the same message, depending on how it's encoded, we'll get different digests. And so we're very particular on what we're feeding these algorithms.
Which is kind of cool because I know this sounds kind of goofy because people are going to be like, Bregg, you're an analyst, you should know. But I, I never looked at it that way, right? Like as a former, developer, design, a web designer, right? I would copy stuff out, you know, marketing would come up with tech, like the proof or text or whatever you want to call it, and you'd pull it out of a document and you put in the browser, not realize or in your editor, not realizing you'd have extra line breaks and stuff like that, right? So,
Yeah.
then quickly you would figure out, okay, I need to strip it down to its barest format, right? So that's where
Yep.
Notepad came into play, right? So it stripped
Yeah.
everything out or it showed you what stuff was hidden. I never thought about like the reverse of that, right? Is okay, you're starting off with something in a text format. Okay, next step up, rich text format, right? Word and PDF. I love that analogy because it helps some of us that aren't engineer kind of grasp that concept. So even though, like you said, it's hello world, but depending on what format it is, that digest is going to be a little bit different. So no, great analogy. Thank you. Sorry, go ahead.
No, it's perfect. So there's a couple links down here, and I'll make sure that we get a PDF version of this for folks to touch. There's there's a really great uh, Stack Overflow article where somebody out there in the community summarized the different file extensions. In my work here, I'm using PEM and dir specifically to denote what the file encoding is. I'm using file naming conventions to try to distinguish what the file is. So extension is the encoding, the name of the file is what the file represents.
Mhm.
So if you spend any time on any of the code base that I'm working with, that's kind of my approach. It's not the only one, right? It's create your own journey. You put five chefs in the kitchen, everybody's going to make something a little different. Um, the other piece to this is Let's Encrypt has a beautiful article. It's actually a bit of a nerd fest if you really want to dive into it. They call it their warm welcome to the ASN1 structure and the encoding rules. Great, great read if you really want to dive into this stuff. Most people are like, yeah, no, thanks. I got other things I want to do. So, um, So back to my original question on this. So when you do the Googles out there and you find, hey, how do I correlate these files? On the left-hand side, you see this code snippet that shows I'm going to use OpenSSL and I'm going to go after the private key, and I'm going to try to extract out its modulus. There's the data, and then I actually send that data through a digest algorithm like OpenSSL SHA-256, and I get this digest. It's this text data here. This is the message digest as a result of sending this data by this command through this command. Um, so this output is being passed through this algorithm, and I get this digest. Now we can go after the private key, we can go after the signing request, and we can go after the signed public key, and each of these can extract out the modulus. We can pass it through an algorithm. The command here is slightly different for each one, but the digest here, this field here is the same for each one of these. And
I see that.
that works great.
Yep.
So back to our original four questions, yes, yes, no. The reason why this doesn't work, and we'll cover this in a second, it's not key agnostic. It's specific to RSA. And this took me quite a while to kind of unpack and understand, like, what am I looking at? How does this make sense? Um, so th that took a little bit for me. Um, I have a solution. I figured it out. Turns out I'm not the only one, and we'll get to that. So in my research, I started to formulate this thought or this understanding of there's different pieces to the certificate. So over here on the left is a certificate from the website badssl.com. It's one from that I pulled earlier this year. No, it's not the ones you're going to see today. It's probably not the one you're going to see next month, so on and so forth. Because with Let's Encrypt, I think about every 30 to 60 days, there's a rotation that happens. Within the certificate, there's all this stuff, the subject name, the issuer, the serial number, the validity period, um, key information. But this other stuff up here at the top, I call that the context. The certificate is for a website. The certificate is for a PC. The certificate is for Aaron Bregg. They're all X509 certificates, depending on the purpose and the use. That context, these fields inside the certificate will be different, right? When we look at the certificate details in a web browser in an operating system, you will often see a certificate thumbprint. Sometimes some tools will call it a fingerprint. It's one or the other. We're talking about the same thing, a fingerprint, a thumbprint. It's the digest. Sorry, so many nomenclatures. Um, the interesting thing on this is that the thumbprint of the certificate is not a field in the certificate, even though it's kind of represented as such, it's not.
Interesting.
Um, and you can prove that by exporting the certificate. You can then export it as a binary file, not as an ASCII file, and then you can run it against the digest, and you'll get the same thumbprint, same digest algorithm as what's represented in the operating system. And again, the key here is the thumbprint that you see in the operating system is the binary form of the certificate, not the text form, which is fine. Um, Digital signatures, this will sometimes come up. It's like, well, Jason, we'll just track the digital signature. That's a different beast. Um, the digital signature is, in fact, a field within the certificate. And we'll cover this a little bit more detail in the next slide, I think. And it'll make a bit more sense why it's different. So with digital signatures, with public-private key flows, I have a one key and I have another key, and I performed encryption services. And depending on what I'm trying to do, I'm going to use either the public key or the private key to either encrypt data intended for the sole owner of that private key, provides confidentiality, or I'm going to encrypt some data with the private key so that only the public key can decrypt it. Well, that doesn't provide confidentiality. What that provides
Right.
is some sort of authenticity that this thing has been blessed and signed by an authority that we all know and trust. And that's where you see, you don't see it here. That's why you see like DigiCert has a digital signature against this certificate. or let's encrypt in this case. They have a digital signature they've applied to this certificate for bad SSL. It's part of that process. It's a field in the certificate. So this context, its purpose, its use, that's in the certificate. Digital signature, that's in the certificate. Thumbprint is not. Clear? Mud, maybe?
Yeah, no,
Okay.
no. Even I'm catching up. I'm doing a little bit better than I thought.
Oh, no. So this isn't the first time I've done this talking. Each time I do the talk and each time I get some feedback from the audience, it helps me shape it a little bit more. So I
Oh,
sincerely I appreciate this opportunity. So if I didn't bore you before, I'm going to bore you a little bit more. So if you look at the RFC that talks about the structure of
now what's RFC stand for?
request for comments,
Okay.
I'm going to mess this up. So if you're not familiar with RFCs, some really smart people out there, IEEE, I'm going to mess this up. Uh, Fun fact, we had an intern at an employer who he was on the team or he was in another team. He was asking over the fence, "Hey, security guys, I'm interested in what you do over there." So my colleague was sitting with him and he was having a warm talk and conversation. And they were talking for 20 minutes. And finally the kid raised his hand and because my colleague was talking about log analysis and CloudTrail logs and all this stuff. And he's like, what's a log? I mean, this kid's straight out of high school or he's like fresh into college. For me, that's a reality check. Like, know your audience, but don't always assume, right? So
Right.
I appreciate the ask on this. So RFCs, it's a way for the internet community. You got a bunch of IT nerds out there, and if you don't have a set of standards, what is IT going to do? I'm going to create my own version of it, and then nobody's things are going to talk one to the next. So what the RFCs are intended to provide is a set of standards of how the data should flow, how they should communicate, how they should structure the information. This particular RFC focuses on X509 certificates with public key infrastructure, and it goes into describing what that certificate structure should look like when it's packaged as a binary file. Um, it's a little bit of a head tilt to look at this, but if you look at these fields, this kind of looks like I want to say this is like a C structure, but I don't think it is. I think it's its own. And this is where I don't want to mislead anybody, but the, 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 the things to take away from here is you've got this TBS certificate, which contains this value. Well, this value represents this entire structure here. And then at the bottom of it is the signature algorithm. Remember that digital signature we talked about a moment ago? And
Yep.
then the digital signature string. So that's the output. So here's this algorithm, say SHA-256 by RSA. I encrypted it with an RSA key, and the signature algorithm or the digest algorithm that goes with that signature is SHA-256. That's what you'll see here. And then because it's a digital signature and we did encryption, that ciphertext, if you will, that's this nonsense. But I'm going to focus here on this TBS. TBS stands for, as near as I can tell, to be signed certificate. Here's all the stuff that are packaged together, give it to my CA, you sign it, you give it back to me. It's structured in a new format that's been blessed. I'm going to install that in my web server. Inside this structure is the certificate version, the serial number, signature, the issuer fields we're starting to be familiar with.
Mm-hmm.
The validity, the subject. Hey, what's this? Subject public key info. That's unique. That's different. We talk about extensions all the time with certificates. Server authentication, client authentication. These are different extensions. That's all contained in this structure. Any changes to any of these fields, I'd update the validity period. Changes my digest of my file, my certificate file. It changes my signature value. Any changes to it. The nice thing about using having something like an ASN1 structure, or the binary structure, um, is if you can have parsers that can parse that data. While it starts out in a binary form, you and I can't necessarily read it unless we're binary people. You can have tools that Let's Encrypt article points to a JavaScript parser. Wireshark can also parse your certificates. So if you dig into the TLS handshake and you pull out the certificate chain, you can actually see this structure in Wireshark. You see something
Interesting.
similar with JavaScript tool. And what you start to see is, hey, for RSA keys, there's this structure, there's this field here that says the algorithm, and then there's this subject key, subject public key field, and then there's a modulus and there's an exponent. Okay, well, for an elliptic curve, wait, elliptic curve, there it is. There's no modulus for elliptic curve. Wait, the structure's different. It's a different algorithm. It's a different key.
Mm-hmm. Mm-hmm.
One might say, hey, this is the difference between a Chevrolet and a Volvo vehicle, right? Wildly different. They both go on the road. They both provide encryption in this case, but they do it in different ways. They have different inputs. They have different things that they use in order to function. And this is what started to have a light bulb go off my head. Rather than focus on the singular element within a particular algorithm, this field here, this field here, this field here, what's that? Can I focus on that? Can I extract that out of the certificate data? Um, and so that's what I did. Questions on that so
What did
far?
what mysteries did you unlock? Let's
Uh,
go to now. I'm
yeah,
intrigued.
yeah. So I want to kind of fold this back. This I might lose some people, and so I use this analogy. My wife and I, we have a key to the house, right? Um, Key being, in this case, think of a key to the house, kind of like an encryption key for X509. So I have my context. Jason adds his bling to his key, right? All the things that personalize it for Jason.
Mhm.
And she has her context. She has her things that she uses to personalize her key, right? His and hers. But the thing that does the encrypting, the locking and unlocking, that's the same. So when we create a thumbprint of everything about this key, it's everything about the key, the whole thing. It's the context and it's the key material.
Mhm.
And that thumbprint for mine and for hers is going to be unique and different because she's personalized it different from me. Therefore, our thumbprints for the entire certificate or for the entire key is different. Make sense?
Because I mean, in the diagram, so for people that are listening in, the diagram is really neat. So you have a key that crosses over, but inside his key content, he's showing like camping and kayaking and stuff like that,
Yep.
all the information related to his key, so to speak. The other graphic is like her key, so family, her Jeep, liking Hello Kitty. So even though the digital signature is the same, the SPKI digest is the same, because there's different content in it, it's going to give you that different thumbprint, which in turn becomes unique. And I like
So,
this is a good analogy for, because thumbprints, everybody understands it for what is it for the most part. I mean, there's one in a million or bazillion or whatever. People could have similar thumbprints, but overall thumbprint to human being is still unique. So yes, thank you.
so just a quick point of clarification. This digital signature embodies both the key material and the context data. So any changes here affects the digital signature.
Ah, okay.
So
Okay.
his digital signature and her digital signature are going to be unique and different. When we
Okay.
talk about the subject public key, that particular field, I'm going to back up here. If we focused on this field only, if we focused on this field alone and anything in it, not any of this other data, not any of this other data,
Hmm.
specifically on this, that that will be the same between both. But the digital signature and the thumbprint, because of this change here, those will be unique and different. And that's why.
Okay.
Yep, yep.
Okay.
And it's slippery, right? So like, you're talking about thumbprint. Oh my goodness, I just want to go erase my fingers. Um, and we'll cover this, and I hope that we don't mix terminology too much, but it's like I said, sorry. By the end of this, what you'll see is we talk about a certificate thumbprint, maybe this guy up here, and then we talk about an SPKI thumbprint, or some might call it a private or a key thumbprint, different than the certificate. Certificate's the embodiment of that whole thing. So the solution to this, NerdFest. So where before we were doing OpenSSL RSA, I hope this comes through okay. I try to make the font large enough. We use OpenSSL, but we use a combination of a different set of command options to get the same data. Um, this is a data set that I pulled from one of my sample datas a while back. So um, it's just an example. So in this case, we're going to use the P key option of the OpenSSL. We're going to input either in binary or ASCII form one of these versions of the private key, and we're going to extract out the public key. Now, the private key of a X509 isn't included in the private key. What we're doing is we're asking, hey, I need you to derive the public key from the private key material. Does that make sense?
Yep. Yep.
So we're deriving the public key using the private key as its source. This is proof of concept. I don't have a password on it, so don't shame me, right? There is a password option you can add to this. I'd have to look it up to see what it is, but if you do the help on OpenSSL, you'll see it. So private key, depending on either of its forms, I get this digest chasing after this P key, at least looking at the public key data. And the key here, again, no fun, no pun, is that I'm doing a digest against the binary form of that. With certificate signing requests, and this is typical if you're not familiar with certificates, I'm a system admin and I generate a private key. And then I go through this process and I generate a signing request that has my subject on it. I say, this is for this web server. Here's what its intent is. I'm going to generate that signing request and I'm going to give that signing request to a signing authority who's then going to look it over. Hey, is everything cool? Is everything good? Is Jason authorized to ask for this certificate for the environment? If yes, then they give you back in response to your signing request to give you a signed public key. So in this second set here, I'm using the rec option here to look at a signing request. Slightly different command set because we're doing requisition or certificate signing requests. I'm going to look at that file type, but I have to munge the data. I have to pass it through a couple of these algorithms to extract the data that I need out of it because OpenSSL structures it in some of these cases as ASCII files, but inside the ASCII, there's two sections. There's a private key, and then there's a public key, and then there's the full certificate details. And you're like, then what SED does here says, I'm only interested in the public key. I don't care about that other thing. Just give me that one bit. And then we convert this back from ASCII using ASN1 parse to binary form, and then we compute the digest. There might be a slightly different way, more efficient way of doing this with OpenSSL. I couldn't find it. So the point here is I'm taking this information and the signing request, I'm chasing after a very specific element in that signing request, and I'm computing the digest against its binary form. Similar structure here with an X509 certificate that's been given to me. It's a different argument that you pass to it. In all of this, the digests are the same. I'm like, sweet.
Yeah. Yeah.
I got some common
I
ground
see
here.
that, which is a good way for people like me at a high level to see that's where that's the value of that thumbprint,
Correct.
right? Right.
And the, the emphasis here is understanding what that thumbprint represents. So based on some feedback, I'm like, that's great, Jason. You got this tool, you got this concept. Like, can you make something that's usable? Well, I did. I created a shell script. It's just largely based on OpenSSL. and you feed it private key, signing request, assign public key, and you specify a digest algorithm, and you get, interestingly enough, you get the digest of the file. Now, this is, I have to think about how to approach this. This digest isn't the same as the digest you're going to see with from the certificate from the OS. And the reason is because I'm going after the ASCII file. So that's a little bit misleading. That's literally just a digest of that text file, not of the Word document or the PDF document. But my focus here is across these three different file types, the digest is the same here for RSA keys.
That is
And
pretty slick.
it also works for elliptic curve keys. So I'm still working on making sure that this all works on Kali Linux. A lot of my development starts out on a MacBook, but I make sure to try to make that portable into Linux.
Mhm.
So it's largely there. I got to go through a little bit more testing, but it works. It does what I wanted. And so when I started to get this kind of result data, um, I'm a nerd in the corner with a happy dance, and the wife is like, "What did you do?" So what I just showed you is the culmination of a bit of work. So there's a GitHub repo out there, SPKI underscore OpenSSL. I'm not real original with my GitHub space. So you've got JSON and hex form here in this little project. Trusted Sec, I think, had an article that came out that talked about their tool shells.
Mhm.
I have a space that I have for stuff like this. This is for me, this is the first time I've actually released anything for anybody to contribute to or to consume. I, I don't know what I'm doing with GitHub. So I've been
Oh,
largely,
it's a good way. That's a good way. You're making this stuff. You're
yeah.
making this stuff public. It would be interesting if some listeners poked around in it and see if they could get this functioning. And then obviously, if I remember right with GitHub, they can put you can put comments besides requests, right? You're in the bottom of those, right?
Yeah, so by the time your viewers see this, I'll be a little bit more comfortable because I got a couple colleagues that are going to be working with me on it. But this is out there. I've had a few folks like, "Oh, what you got is like really cool. Are you gonna charge people for this?" I'm a
Not ready
defense.
for prime time or charging. Yeah, right.
Yeah, no. So I'm a blue teamer, right? I'm on the defensive side. I'm not a red teamer or anything like that. But the adversaries, they have so many more resources than we do. And so for me, it's like, hey, this is just an opportunity to look at things a little bit differently to help maybe shore a gap that I'm perceiving. I don't see this as a corner on the market. I'm just using a set of commands a little bit differently than what maybe we've been talking about so far. So what the SPKI OpenSSL, that shell script, what this was all about. There's a Jupyter notebook. If you're not familiar with Jupyter notebooks, what if you're not familiar with those are, I kept coming across those in development communities, and so I pushed myself to look at it. And imagine, if you will, a GitHub README file that's markup syntax interlaced with code segments that you can then execute. And you can execute it as many times as you want. Change your code base, execute, change code. And then you
Mm-hmm.
can document in the different sections in that notebook what you're doing, why you're doing it, why it's important, why it matters. So for me, I got bit years ago where a change came out on my MacBook and they truncated my history in the command line. I'm like, okay, note taken, Jason, create some documentation on what you learned today, this week, or whatever else. Get it out of your.
Don't just leave it in your noggin.
No, yeah. So there's a notebook out there. There's a RSA set and there's an elliptic curve set in the same notebook where you can generate. You have to set up the environment for it, but I generate one RSA key. I derive the public key material. I generate 5 signing requests. You can go into the notebook and say, I want to create 50 notebooks or 50 signing requests. It doesn't matter. These n number of signing requests are all based on the single private key. But the contents of the signing request is unique and different. It's a different GUID, it's a different subject name, the validity periods are all different. It's just mixing it up. And then we display some certificate details. We extract this subject public key thing that I'm yammering about. And then we compare the digests. And what you get is I've got multiple signed certificates, but I've got one subject public key info. I've got all this, each certificate's got a unique certificate thumbprint, but the SPKI thumbprint, there's only one. It's all the same for all of these things. Um, so a little bit backwards, but this work helped me create this script. Does that make sense?
Yes. Yes. And it works on Kali Linux.
It does. In preparation for this, I found, and I knew this was going to show up, and I'm glad I saw it now. Different commands on Mac and versus Windows behave a little differently. And I found out that the file command that I use to indicate what the file type is on Mac behaves slightly different than it does on Kali. And so I got to tweak the code a little bit to support that. But it's by the time viewers will see this, it'll be fixed. But I'm trying to make it cross-platform compatible, and I'm also trying to put it in the space, Kali Linux, that's approachable and accessible by a broader audience. I don't want to assume that people are Mac people. It's just where I start, but trying to go out and put it out in a place that's call it the watering hole, Kali Linux.
Well, and it's a good way for people to get a hold of you as well.
Yeah.
Yes, as we're running up against it and we're kind of finishing stuff up. Oh, wait, there was one more.
Yeah, so I will be quick on this. So we talked about this. Um, so taking that shell script, the open SSL, I use the bad SSL. I'm like, okay, can I inventory my environments? I created a Python version of this that actually crawls an environment. You feed it a list of environments, a list of sites. It goes out and fetches those websites. It grabs the certificate. It also pulls the server name indication or accesses the website, whether it's got SNI turned on or not. For those not familiar with SNI, it's a way of overloading multiple websites on a single IP and a single port, but it traverses TLS. It's not just going after the host header inside of an HTTP GET request. It's happening earlier in the TLS handshake. Hosting providers use this quite a bit to say, I'm hosting a lot of things for all my different customers. Each customer's got a different environment. I'm going to use SNI to distinguish one customer's environment to the next on my limited infrastructure, limited being IP space. More nerd fest. So I've got my SPKI OpenSSL thing over here on the left, and then I created this Python. It generates the same digest for the same data sets. Now, in this particular case, this morning I pulled the bad SSL website certificate. I can show you the difference between these two fields. Analysis of bad SSL. I did ask for permission. Thank you to April and her team for giving me thumbs up. Why this is important. If I just focus on the certificate thumbprints alone, I'm going to miss something. So I color coded this because I realize it's a wall of text. Imagine, if you will, I had a site that was compromised. I had a key compromised, this orange website. There's one occurrence of this thumbprint in the environment. I'm going to go after that one because that's what I focus on. The certificate thumbprint, that's what I traditionally would look at. This is something, where else does this thumbprint exist? Just the one environment. Conversely, if I had problem with the purple web environment, just one of those, I've got 71 of these out there.
And that's a big difference.
It
Big
is.
difference.
It is. And so I'm using the thumbprint of the certificate file in its entirety, and that's what I'm focused on. If I change my emphasis and I say, hey, you know what? If I add JSONs, so over here is the certificate thumbprint, the stuff in blue. If I change my emphasis and I include now the subject public key info, that digest information, this stuff in green, what I realize is that this green thing represents the key material itself, whether it's Jason's bling or his wife's bling, it's the key material only. That's all that represents, not any of the other context. And I couple that with the thumbprints in the environment, what I realize is that I have not one or 71. I really have 91 environments I have to go touch because I'm
Interesting.
now taking an inventory of the actual cryptographic key material
Right.
is different. And you can take this a step further. Hey, I just realized that 71 of these, at that magic number, are part of the default web environment. They're default keys, and these other ones are specific web environments. The data's there. You can munge it, you can wordsmith it, you can massage it any way you like. But that Python tool, it was intended to try to help illuminate and prove out, can I do this? Can I show this? Does it give me what I thought it might? Um, Census, they have this data, so there's a vendor out there that's showing this. Um, there's third parties that are doing this. So while I came about this in a very roundabout way, um, I'm not the only one, and the others have come up with this before me. In fact, Harden Eyes, if you're familiar with SSL Labs and their web environment, Ivan
Hmm.
Ristic, this is Ivan's environment. Same digest, same thing, right? This is the certificate thumbprint. This is the key thumbprint, that SPKI thumbprint. And then, ironically enough, Chromium web browser started showing surfacing this data more recently. This is a new development for me. When I started this a year and a half ago, this wasn't there. Um, and so for me, it's like, ta-da. Does anybody?
Well, validates that the research you were doing obviously was valuable if companies like Google and other places are investing to make it shown to or shown to people, not customers.
Right.
So,
It takes confidence of like, hey, I've done some arithmetic and hey, I'm getting the same result as other people. So my hope is that with these tools, with these perspectives, that can help raise awareness to other people. Like, what are these fields? Why do I care? What is the difference? Um, so long story short, Shell and Python versions of this that you can answer these questions of, yes, I can correlate, I can inventory, and I can also prove rotation by tracking the subject public key digest. I can track that over time and I can say, up, no, this one to the next rotation or this renewal is unique and different. Um, are all vendors out there inventorying this in their tool sets? Not necessarily. Operating systems don't surface this necessarily, but I think it's coming. I think you'll see it more and more. But when you do start to see it, do we understand what it means, what it's telling you, why you might focus on one versus the other? Hopefully this work helps answer that.
and then our last question, we went from no to yes. Yes, we can support different key types.
And
Excellent.
there's a nerd fest. So apologize, I got a little bit long-winded in there in the middle, but
Oh, it was good stuff. For those listening on the podcast, we'll make sure to put this information in the podcast description link so they have access to it. It's got Jason's email, got access to the code, to the code itself, and the Python, and then you had a couple different, we were going to link some different articles. You, if I remember right, early in the slide, there were a couple different articles that we
yeah,
want to
yep,
get
yep,
linked.
yep. We can connect on those, make sure they get those links if they're not covered in the PowerPoint in its PDF forward. Sorry, in its PDF format. Make sure that those are accessible so that we can share the resources. Certainly.
Excellent. Look at that. And you did it with just a couple minutes to spare.
I was targeting 45 minutes, but it's such an interesting topic for me, but it's hard to not drop out at the command line. So I tried to sharpen the screen captures. I think a live demo is a different audience and
Oh
probably a
yeah,
different venue,
100%.
sure. But no, this stuff it's fun, it's interesting. So how can we help raise awareness and help education?
Which is good. We want more security education, the better. Jason, I want to thank you very much. I know that going back to the original concept of this when we were talking at GrrCon, and it went from just a casual talking point to here it is in fruition. So I absolutely appreciate your time.
You're welcome. Glad to help. Thank you for the opportunity to share. Sincerely.